the greatest prison humanity may ever face is not on Earth. It is not gravity. It is not distance. It is not death. It may be the universe itself. For thousands of years, humans looked at the stars and saw freedom. Ancient civilizations mapped constellations. Dreamers imagined distant worlds. Scientists built rockets. Engineers pushed machines beyond the atmosphere. Step by step, humanity transformed space from myth into destination. First, we escaped the ground. Then we reached the moon. Then, we sent machines to every major planet in our solar system. Now, for the first time in history, serious conversations are happening about Mars colonies, interstellar probes, generation ships, cryogenic sleep, warp drives, and civilizations spreading across the stars. The future seems obvious. Earth is only the beginning. The solar system is only phase one. The Milky Way is next. And one day, perhaps humanity leaves our galaxy behind. That is the dream. But there is a terrifying possibility almost nobody talks about. A hidden law written into the fabric of reality may make that final step impossible. Not difficult, impossible. Even if humanity survives for millions of years, even if technology becomes almost godlike, even if we conquer aging, disease, and energy, the cosmos itself may still lock us inside the Milky Way forever. This is not science fiction. This is physics. And according to some of the deepest ideas in cosmology, the very structure of space-time may already be closing the exits. Most people think space is like an ocean, big, dangerous, hard to cross, but crossable. Build a better ship, travel faster, live longer, eventually you arrive. That logic works on Earth. It even works in theory inside parts of our galaxy. But on the scale of the universe, space does not behave like an ocean. It behaves more like a trap that expands while you are trying to escape it. This changes everything. Right now, the Milky Way contains somewhere between 100 and 400 billion stars. That number alone feels almost infinite. Our sun is just one of them. Our solar system is a tiny neighborhood inside one spiral arm of a galaxy so vast that light, the fastest thing in the known universe, needs about 100,000 years to cross it. That means if you could somehow travel at light speed, breaking every engineering challenge humanity has ever faced, you would still need longer than recorded human civilization just to cross our own galactic home. And yet, the Milky Way is not special. It is one galaxy. One. Current estimates suggest there may be hundreds of billions, perhaps even trillions, of galaxies scattered across the observable universe. Each one filled with stars, planets, possibly life, possibly civilizations. The scale is almost beyond comprehension. So naturally, people assume the path is simple. Advance enough, expand outward, reach other galaxies. But here is where reality becomes deeply unsettling. The universe is not static. It is not sitting still and waiting for us. Since the birth of the cosmos nearly 13.8 billion years ago, space itself has been expanding. This is one of the strangest truths in science. Galaxies are not merely flying through empty space like bullets. The space between galaxies is stretching. The universe is growing larger. This means distant galaxies are not just far away. They are becoming farther away all the time. And not because their engines are running, because reality itself is expanding beneath them. This idea alone is hard to grasp, but it gets worse. In the late 1990s, scientists discovered something shocking enough to change cosmology forever. The expansion of the universe is speeding up, not slowing down. Speeding up. This was the opposite of what many expected. Gravity should have been gradually pulling everything together, or at least slowing the expansion over immense timescales. Instead, something mysterious was overpowering gravity on cosmic scales. Scientists called it dark energy. Dark. Energy may make up roughly 70% of the universe. And to this day, nobody fully knows what it is. Think about that. The dominant force shaping the fate of the cosmos may be something humanity still barely understands. And this invisible force may be creating a final border no spacecraft can ever cross. This is where Brian Greene and other cosmologists force us to confront a brutal possibility. There are regions of the universe we can see today that we may never, ever reach. Not because we are too weak, not because we are too early, but because physics may permanently forbid it. Every second, distant galaxies move farther beyond our grasp. Some are already receding so quickly that even light traveling toward us from those regions will never overcome the expansion. This creates something almost unimaginable, a cosmic horizon, a boundary beyond which access may be permanently denied. In other words, parts of the universe are slipping away forever, right now, at this very moment. And over unimaginable stretches of time, more and more galaxies may vanish beyond that boundary until future civilizations could look outward and see only darkness. No distant galaxies, no evidence of the vast universe we currently observe, just local remnants, an isolated cosmic island. That means humanity may live during one of the few eras when the larger universe is still visible. This is a profound and chilling thought. We may not simply be early explorers. We may be living before the doors. Close. In this video, you will discover why the real obstacle to escaping the Milky Way may not be propulsion, biology, or intelligence. It may be dark energy. It may be cosmic expansion. It may be space-time itself. You will see why crossing interstellar space is already a nightmare, why intergalactic travel may be fundamentally different, why even hyper-advanced civilizations could face hard cosmic limits, and why the universe may be building invisible walls faster than any species can outrun them. By the end, the biggest question may no longer be whether humanity can conquer space. It may be whether the universe ever intended us to. Welcome to the channel. Subscribe because this journey is about to challenge everything you thought you knew about freedom among the stars. At first, the dream seems possible. The Milky Way is enormous but not infinite. That distinction matters. Our galaxy stretches roughly 100,000 light years from one side to the other. It contains spiraling arms, violent nebulae, black holes, dead stars, newborn suns, and perhaps billions of planets capable of supporting life. To the human mind, that scale feels overwhelming. It feels almost absurd to believe we could ever cross something so vast. But in cosmic terms, the Milky Way can create a dangerous illusion because despite its terrifying size, it is still a single structure, a connected island. And physics, at least in theory, does not completely forbid movement across it. This is where many people misunderstand the true challenge. Crossing the galaxy is brutally hard, but hard is not the same as impossible. Even with technology humanity does not yet possess, scientists can still imagine methods that might one day allow galactic expansion. Generation ships, for example, are one possibility. These would not be ships built for one crew. They would be moving worlds. Entire societies living and dying on board over centuries or even millennia as descendants continue the journey. Then, there are suspended animation concepts where travelers sleep through vast stretches of time. There are self-replicating probes, often called von Neumann machines, which could theoretically spread from star system to star system by using local materials to build copies of themselves. This idea is deeply unsettling. A single machine civilization could, in theory, spread through the Milky Way without requiring biological survival at all. Some calculations suggest that even at speeds far below light speed, perhaps just a small fraction of 1% of light speed, a determined civilization could colonize much of the galaxy in tens of millions of years. That sounds impossibly long to us. But the Milky Way itself is over 13 billion years old. On galactic timescales, tens of millions of years is a blink. This creates a seductive assumption. If one civilization survives long enough, spreads slowly enough, and builds carefully enough, the galaxy itself may eventually become accessible. Not easy, not quick, but possible. And this possibility shapes human optimism. If we can reach nearby stars, then distant stars, then the galactic core, then the outer rim, step by step, the Milky Way begins to feel like a map waiting to be explored. But here is the hidden trap. This logic works only because the Milky Way is gravitationally bound. Its stars are moving, yes, but the galaxy itself holds together as one enormous system. Inside it, distances are vast but relatively stable compared to the larger universe. Beyond it, everything changes. Intergalactic space is not simply more of the same. It is not just a bigger ocean. It is a fundamentally different battlefield. Between galaxies lies space so empty and so immense that even nearby galactic neighbors are separated by distances that make the Milky Way seem almost small. And worse, those distances are not standing still. Inside our galaxy, movement is mostly a problem of engineering. Outside it, movement becomes a problem of cosmology. This is the first great illusion. Humanity may eventually learn to navigate stars. We may spread through our galactic home over unimaginable stretches of time. But conquering one island does not mean the sea beyond it obeys the same rules. Because the moment we look past the Milky Way, we are no longer fighting distance alone. This is where the universe reveals its cruelest trick. Most people think galaxies move through space the way ships move across water. A galaxy goes one way, another goes another way. Build something fast enough, and eventually you catch up. That idea feels logical. It is also deeply misleading. On the largest scales, galaxies are not simply traveling through a fixed cosmic emptiness. Space itself is changing. This was one of the most shocking discoveries in modern science. In 1929, astronomer Edwin Hubble noticed something strange while studying distant galaxies. Their light was stretched toward the red end of the spectrum. This redshift suggested they were moving away from us. At first, this seemed dramatic enough, but the deeper truth was even stranger. Almost every distant galaxy appeared to be moving away from every other galaxy. Not because Earth was special, not because we were at the center, but because the universe itself was expanding everywhere at once. This changed humanity's understanding of reality forever. The Big Bang was not an explosion into empty space. It was the expansion of space itself. That means galaxies are often being carried apart not by engines or force in the normal sense, but because the fabric of the cosmos between them is stretching. A common analogy compares this to dots on an inflating balloon. As the balloon expands, every dot sees other dots moving away. No dot is the center. The surface itself is growing. But even that analogy is limited because the real universe expands in ways that challenge ordinary intuition. The farther away a galaxy is, the more space exists between you and it, and because all that space is expanding, more distance means faster recession. This is called Hubble's law. In simple terms, distance itself becomes an enemy. A galaxy twice as far away is not merely farther. It is being pulled away faster by the expansion of space. Push this far enough and something astonishing happens. At extreme distances, galaxies recede faster than light. This sounds impossible. Einstein taught us that nothing can move through space faster than light. That remains true. But here is the loophole. Space itself can expand without obeying that speed limit. Galaxies are not breaking the laws of physics by racing through space faster than light. Instead, space-time itself is stretching so rapidly that the distance between galaxies increases faster than light could cross it. This is one of the least understood ideas among the public. There are galaxies whose current light will never reach certain destinations, no matter how long anyone waits. Not because the light stopped, not because the galaxy vanished, but because the space in between expands too quickly. This creates a terrifying implication for future explorers. Some destinations are not just far, they are permanently retreating, Even a perfect spacecraft traveling at light speed could fail to arrive if space-time expands too aggressively between departure and destination. In other words, there are parts of the universe where the finish line moves away faster than you can approach it. This transforms cosmic travel from a challenge of fuel into a battle against geometry itself. And the numbers are staggering. The observable universe is about 93 billion light years across, yet it is only 13.8 billion years old. That sounds impossible until expansion explains it. The universe grew while light traveled. Distance itself was never static. So when humanity looks at the stars and dreams of escape, we are not staring at a frozen map. We are staring at a map that is stretching, shifting, and tearing pathways apart in real time. And then scientists uncovered something even more disturbing. Expansion was not merely continuing, it was accelerating. For much of human history, gravity seemed like the ultimate ruler of the cosmos. Gravity builds stars. Gravity shapes planets. Gravity pulls galaxies together. Gravity bends light. Gravity governs motion on scales so vast they defy comprehension. So for decades, many scientists assumed gravity would also control the long-term fate of the universe. The question was simple. Would cosmic expansion slow down enough for the universe to coast forever? Or would gravity eventually pull everything back together in some final collapse? Both possibilities assumed one thing: expansion should be losing momentum. But in 1998, that assumption shattered. Two independent teams of astronomers were studying distant exploding stars called Type 1a supernova. These stellar explosions act like cosmic measuring tools because their brightness can reveal distance. Across unimaginable scales, the goal was to track how expansion had changed over time. What they found stunned the scientific world. Distant galaxies were not slowing down. They were speeding up. The universe was expanding faster over time. This was one of the most shocking discoveries in modern physics. Something enormous was overpowering gravity itself, something invisible, something still deeply mysterious. Scientists called it dark energy. The name sounds dramatic, but it hides a profound ignorance. Dark energy is not fully understood. It may be a property of empty space itself. It may be vacuum energy. It may represent something even stranger. But whatever it is, current evidence suggests it makes up roughly 68 to 70% of the total energy content of the universe. That means the force shaping humanity's ultimate cosmic future may be something we barely comprehend. This is where the true horror begins. Dark energy does not simply push galaxies apart. It accelerates the separation. The farther the universe evolves, the faster vast regions become unreachable. This creates a boundary known as the cosmic event horizon. This horizon is not a wall. It is not a physical object. It is a limit written into space-time. Cross it and return becomes impossible. Even worse, crossing may not require movement at all. Galaxies can simply drift beyond reach because expansion carries them away faster than light can ever bridge the growing gulf. This is one of the darkest truths. In cosmology, there are galaxies visible today whose future light will never reach us forever. We are seeing some of them as they once were billions of years ago, while their present reality is already slipping beyond permanent access. In a sense, parts of the universe are disappearing before our eyes, not visually all at once, but physically, causally, forever. Over billions or trillions of years, more galaxies will cross this horizon. One by one, entire galactic civilizations, stars, and possible worlds will fade beyond interaction. No message, no spacecraft, no rescue, no exploration. Even a civilization with perfect engineering and light-speed travel would lose access once these regions pass that threshold. This is not a technological failure. This is a built-in property of cosmic architecture. The universe is gradually isolating its islands. Astronomers estimate that around 100 billion galaxies are currently observable, but in the far future, most of them may vanish from view, entirely for observers inside our local group. Future astronomers may look outward and detect only darkness beyond their merged galactic home. They may never know other galaxies existed. The evidence will be gone. This means humanity may live during a rare cosmological window when the broader universe is still detectable. A brief era before the lights beyond our neighborhood disappear. Dark energy is not merely stretching space. It may be erasing opportunity, closing doors, silencing reachable futures, and among all the galaxies facing this slow separation, one small cluster may become humanity's final refuge. Not everything is being torn away, at least not yet. While dark energy dominates the largest scales of the cosmos, gravity still holds power in smaller regions where matter is tightly bound together. And humanity exists inside one of those rare pockets. This pocket is called the local group. It is our cosmic neighborhood. Compared to the visible universe, it is tiny, but compared to human history, it is staggeringly vast. The local group contains more than 80 known galaxies, though most are small dwarf galaxies. Two giants dominate this region: the Milky Way and Andromeda. The Milky Way is our home. Andromeda is our largest neighbor. It sits about 2.5 million light years away, which sounds unimaginably distant. Yet in cosmic terms, Andromeda is close enough that gravity has already overpowered expansion between us. This is a crucial detail. Not all galaxies are fleeing forever. Some nearby systems are bound tightly enough that dark energy cannot separate them. Andromeda is not drifting away. It is coming toward us. Right now, at roughly 110 kilometers per second, our neighboring galaxy is on a collision course with the Milky Way. That sounds catastrophic, but galaxies are mostly empty space, so individual stars are unlikely to smash directly into one another. Instead, over billions of years, gravity will reshape both galaxies in a slow-motion cosmic transformation. Their spiral arms will distort. Gas clouds will collide. New stars may ignite. Black holes at their centers may eventually merge. Astronomers sometimes call this future galaxy Milky-Way. This merger is expected in about 4 to 5 billion years. By then, Earth itself may already be uninhabitable due to the sun's evolution. But for whatever descendants of humanity or successor civilizations exist, this event may define their final galactic homeland. And it may not stop there. The Triangulum galaxy, another member of the local group, could also become part of this future structure, along with countless dwarf galaxies gravitationally trapped in the same region. Over immense spans of time, our local group may collapse into one giant elliptical galaxy surrounded by darkness. This is where the larger tragedy unfolds. Beyond our local group lies the Virgo supercluster and billions of distant galaxies. For now, many are visible. For now, they can still be studied, but dark. Energy will continue stretching the space beyond our gravitational island. Slowly, relentlessly, external galaxies will recede past the cosmic event horizon. One by one, they will disappear from practical reach. Eventually, even their light may fade from detectability. Future astronomers living trillions of years from now may look into the sky and see only their merged local galaxy. No Hubble deep field, no distant spirals, no evidence of a Big Bang expansion. Some cosmologists suggest these. Future observers could struggle to discover the true history of the universe because the proof will be gone. The cosmos may appear static and lonely, a vast darkness surrounding one galactic remnant. This means humanity may currently live in a scientifically privileged era. We can still observe the wider universe before it vanishes behind accelerating expansion. In the far future, the accessible universe may shrink from trillions of galaxies to one isolated structure. One final island in an ocean whose shores have disappeared. For a species that dreams of infinite expansion, this possibility is devastating. Humanity may not inherit an endless cosmos. We may inherit a shrinking archive, a fading sphere of reachable existence where our descendants rule one colossal galactic kingdom, while the rest of creation slips forever beyond the edge. And even then, the question remains whether intelligence, no matter how advanced, could ever break that boundary at all. Humanity often believes every barrier is temporary. Mountains fell to roads, oceans fell to ships, the sky fell to aircraft. Gravity itself fell, at least partially, to rockets. This pattern shapes one of our deepest assumptions. Given enough time, intelligence solves everything. A problem may be difficult today. It may even seem impossible for centuries. But eventually, technology wins. That belief has powered civilization. It may also be dangerously incomplete, because cosmic expansion introduces a terrifying possibility. Some barriers may not be waiting to be solved, they may be absolute. At first glance, the answer seems obvious. Build faster spacecraft. Chemical rockets are weak, so use nuclear fusion. Fusion is limited, so use antimatter. Antimatter is risky, so invent something better. Push harder, go faster. Approach light speed itself. Einstein's relativity allows objects with mass to move incredibly close to light speed, though reaching light speed exactly would require impossible energy. Still, many assume near light speed travel should eventually unlock the universe. For interstellar journeys, this may help. For intergalactic escape, things become far darker. The problem is not simply speed. It is the race between velocity and expanding space-time. If a distant galaxy is moving away because space itself is stretching faster than your ability to close the gap, your engine becomes irrelevant beyond a certain point. This is deeply counterintuitive. A spacecraft could be moving locally at astonishing speed, yet the destination may still recede overall because the fabric of reality between traveler and target keeps expanding. It becomes a race against a road that lengthens faster than you can run. This is why more energy alone may fail. You are not merely overcoming inertia. You are confronting cosmological geometry. Even stranger, relativity introduces brutal consequences for extreme travel. Near light speed journeys create time dilation. Travelers may experience less time, but the outside universe continues evolving. Entire civilizations could rise and vanish while one ship races onward. Reach a distant destination after subjective decades, and your origin may already be ancient history. And all this still assumes the destination remains reachable. Then come the speculative escape routes, wormholes, warp drives, space folding. These ideas dominate science fiction because they bypass conventional limits. A wormhole could, in theory, connect distant points instantly. An Alcubierre-style warp drive proposes compressing space ahead and expanding it behind. These concepts sound revolutionary. They also face enormous unresolved problems. Many require exotic matter with negative energy density, something never demonstrated in usable form. Quantum instability may collapse such structures. Energy demands may exceed anything physically practical. Some calculations suggest quantities rivaling stars or even planets. At present, these remain mathematical. Possibilities, not engineering blueprints. This distinction matters. Physics allows many equations. Reality does not guarantee implementation. And here lies the deepest fear. The universe may not care how intelligent a civilization becomes. A species could master genetics, artificial intelligence, Dyson spheres, black hole engineering, yet still confront boundaries no machine, no empire, and no godlike science can cross. This would mean intelligence is not freedom. Not fully. There may be regions forever sealed by the structure of space-time itself, invisible borders more final than walls, weapons, or extinction. This possibility reshapes the Fermi paradox as well. Perhaps advanced civilizations are not absent because life is rare. Perhaps they are isolated, trapped in their own gravitational islands, watching distant galaxies fade exactly as we may one day watch ours. The final enemy may not be self-destruction. It may be a universe designed with unreachable horizons where progress expands power but never abolishes the cage. And that leads to an even deeper psychological shock, one that strikes at the core of humanity's vision of destiny. For centuries, progress has felt limitless. Each generation shattered barriers the previous one thought permanent. We crossed continents once believed unreachable. We split the atom. We mapped DNA. We stepped onto another world. This pattern shaped a powerful belief deep inside modern civilization. The future expands. No matter how hard the obstacle, tomorrow will reach farther than today. This belief is more than optimism. It is the foundation of human ambition. It drives exploration, science, empire, innovation. The assumption is simple. Knowledge grows. Technology grows. Reach grows. Eventually, everything becomes accessible. But cosmology delivers a deeply uncomfortable challenge to that story. Progress may increase power without granting infinity. Humanity may advance beyond anything we currently understand. We may colonize planets, build artificial habitats around stars, spread through the Milky Way, perhaps even master energies that feel almost divine by present standards. And still, most of existence may remain permanently beyond us. Not because we failed, because the clock was already running. This is the deeper psychological shock. The universe may contain endless wonders, but timing may decide which ones can ever be touched. Right now, humanity lives in a strange era. We are late enough to understand cosmic expansion, late enough to detect dark energy, late enough to realize galaxies are disappearing beyond reach. But we may also be early enough that some nearby cosmic opportunities still remain. This creates a haunting paradox. We may be among the first beings capable of understanding the prison while also being far too late to escape most of it. That idea cuts against one of humanity's oldest instincts. We often fear emptiness. An empty universe feels lonely. But the darker possibility is not emptiness. It is abundance without access. A universe overflowing with galaxies, stars, planets, and perhaps civilizations, yet separated by laws no intelligence can overcome. This is not scarcity. This is exclusion. A banquet visible through glass, and over trillions of years, the glass may thicken. Future descendants may inherit extraordinary power inside their shrinking cosmic island while knowing the greater universe once existed beyond it. That knowledge alone could become a kind of civilizational grief. Ancient humans once looked at oceans as impossible boundaries. Future beings may look at dark cosmic voids the same way, except with one devastating difference. No ship will ever cross. There is also a lesser-known scientific tragedy hidden here. Because as distant galaxies vanish, evidence vanishes with them. The universe may not only become unreachable, its history may become unknowable. Future astronomers may lose direct proof of expansion, the cosmic, microwave background, and the large-scale structure we now use to reconstruct reality. In some far age, intelligence could become trapped not only physically, but historically, living inside a smaller truth. This means our era may be uniquely precious. We exist during a fleeting window when the cosmos still reveals enough of itself to be studied broadly. We can still see beyond our future island. We can still ask larger questions. That may not last forever. This transforms space exploration from adventure into urgency, not panic, not fear, but awareness. Humanity's greatest limitation may not be intelligence, courage, or invention. It may be cosmological timing. We were born into a universe already changing the locks. And beneath all our dreams of expansion lies one unsettling possibility. The final frontier may not be something we fail to conquer. It may be something that was already closing before we even learned to look up. Across everything we have explored, one idea keeps returning. Humanity may grow powerful enough to reach almost anything inside our galaxy. We may spread across star systems. We may build civilizations that last for millions of years. We may reshape worlds and harness energies that feel beyond current understanding. Inside the Milky Way, the path forward still exists. It is long, it is brutal, but it is not clearly forbidden. And that creates a dangerous sense of confidence. Because once we look beyond our galaxy, the rules begin to change in ways that do not care about ambition. Space itself expands. Dark energy accelerates that expansion. Distances grow not just through motion, but through the stretching of reality. And slowly, silently, the universe begins to separate itself into isolated regions. No engines can fully resist that process forever. No intelligence can negotiate with it. No technology can vote against it. The most advanced civilization may still lose simply because the structure of space-time does not allow certain paths to remain open. This is the hidden boundary, not a wall made of matter, not a barrier made of force, a limit written into the shape of the cosmos. And it leads to a disturbing realization. Progress may not equal freedom. A species can become more intelligent, more advanced, more powerful, and still find itself confined inside a shrinking cosmic neighborhood while the rest of reality drifts away beyond reach. The tragedy is not that the universe is empty. The tragedy is that it is full of places that may never be touched, full of galaxies that may never be reached, full of history that may become permanently inaccessible, and all of it separated by a force that does not respond to effort, only time. So the final question is not about engines or warp drives or interstellar survival. It is something deeper. Not how far humanity can go, but whether the structure of reality ever allowed us to leave in the first place. If you found this exploration worth thinking about, support the channel with a like and subscribe for more journeys into the hidden rules of the universe.